Hi students, in this lecture I am going to discuss refraction. So bending of light due to change in medium is called refraction. Let us see in detail. Let us take this is the boundary between two media. For example, this is air medium and this is water medium. When light is incident, on the boundary, so earlier we have learned reflection, right? Reflection. Suppose this is the angle of incidence. Now you can see light ray, it may bend towards normal or it may bend away from normal. Angle made by a refracted ray with normal, it is known as angle of refraction. That means if there is no change in medium, light ray is supposed to travel in the same direction like this. It is in the same direction. And this light ray, it may bend towards normal. This is now normal. Light ray may bend towards normal or it may bend away from normal. And this bending is due to change in medium. So bending of light ray due to change in medium is called refraction. Okay. This is angle of incidence and this is angle of refraction. Okay. Now first in this we define what is a refractive index. Let us see first a refractive index. Refractive index notation is mu. It is defined as speed of light in vacuum upon speed of light in that medium. For example, we want a refractive index of glass. Then this V stands for speed of light in glass. Okay. Suppose we want refractive index of water. Then this V stands for speed of light in water. So this is the way how refractive index of a medium is defined. C upon speed of light in that medium. And we are knowing that due to change in medium, frequency of light does not change. So we are knowing that V equal to F into lambda, where V is now speed of light. And F is frequency and lambda is wavelength. So when medium changes, frequency does not change. That means from this we can write lambda proportional to V. Okay. This is also written as wavelength of that color. For example, we are focusing red light. Then wavelength of that red light in vacuum upon wavelength of that color in that medium. So refractive index in terms of speed of light in vacuum upon speed of light in that medium. Since V equal to F lambda, frequency is a constant, lambda proportional to V. That means this is lambda in vacuum and this is lambda in that medium. And we are knowing that speed of light is maximum in vacuum, that is C. So if we take any medium, its speed is less than C. So V value is less than C. That means this ratio will be greater than 1. That means for any substance, refractive index is greater than 1. So from this we can write for vacuum, refractive index for vacuum, it is 1. because C by C. Okay. And coming to refractive index for air, it is approximately 1, not exactly 1, approximately. So when we are solving problems, we are taking this as 1 unless until they mention. Okay. So if you are taking for any medium, mu value will be greater than 1. Okay. It is 1 for vacuum. It is approximately 1 for air. For remaining any medium, any substance, it is greater than 1. So mu value can never be less than 1. Okay. Next. So here we define one more thing, that is rarer medium. See what is it? Rarer medium. So when we compare two medium, suppose medium 1, medium 2. When we compare two media, suppose speed is less now in this medium compared to this one. When speed is less, that is called denser medium, in which medium speed is relatively less. Speed is relatively less. That is a denser medium. Where speed is relatively more, that is a rarer medium. Okay. Now let us see here. If speed is less, mu value is more. Speed less, mu value is more. So mu is relatively more. Means when you are given two media which has mu value more, that is denser medium. Mu value is less. That is a rarer medium. That means by seeing refractive indices, we can decide which is denser medium and which is rarer medium. Okay. Now let us discuss Snell's law. See what Snell's law says. Snell's law. For example, this is now first medium, that is mu1, and this is mu2. Angle of incidence psi, angle of refraction r. Then Snell's law says that mu1 sin I is equal to mu2 sin r. That is Snell's law. See from this what we can conclude. For example, mu1 is greater than mu2. See what it means. Mu1 greater than mu2. Mu1 is greater than mu2 means it is traveling from denser to rarer medium. Okay. Now see carefully. Mu1 greater than mu2. In that case, I will be less than R. I will be less than R. When mu1 is greater than mu2, I will be less than R, because mu1 sin I equal to mu2 sin R, right? These two are equal. Its meaning is that when light ray travels from denser to rarer medium, it will bend away from normal. Let us make a diagram for this. This is now instant ray. If there is no change in medium, it is supposed to travel in the same direction. Okay. But because of refraction, it is now bending. It is bending. And condition given that mu1 greater than mu2. So denser to rarer medium. Then it bends away from normal like this. Bends away from normal. So you can see now this angle is R, which is greater than I. Okay. Now take reverse case. If mu1 less than mu2, that means light ray enters denser medium. Then that implies I is greater than R. That means you can see diagram here. The first one, if mu1 less than mu2 means entering into denser medium, then light ray bends towards normal. You can see this total angle is now I, right? This total value is I. This is now R, which is less than I. Okay. So whenever light ray travels from denser to rarer medium, it bends away from normal. This is now R, which is greater than I. If light ray travels from rarer to denser medium, it bends towards normal. This is I and this is R, right? Now from this we can say deviation. Deviation is equal to modulus of I minus R. So why taking modulus means if you take now in this case, it is R minus I, which is a positive value. In this case, I minus R, that is a positive value. That's why we are taking here modulus of I minus R. That is giving us a deviation. Okay. Let us see now the same Snell's law in vector form. That is taken in vector form mu1 into it is A cap cross n cap, that is equal to mu2 into B cap cross n cap. So here n cap stands for a unit vector along the normal at the point of incidence. I am repeating, n cap is unit vector along the normal at the point of incidence. A cap unit vector along the instant light ray, and B cap unit vector along the refracted ray. This is now Snell's law in vector. Okay. Let us see now the points till now what we have discussed. So bending of light due to change in medium is called refraction. Next, if speed of light is relatively less in a medium, then that medium is denser medium. Speed is relatively less. If a speed of light is relatively more in a medium, then that medium is a rarer medium. So for denser medium, refractive index is more, and for rarer medium, refractive index is less. So these are the points we have discussed till now, right? Let us now move on to apparent depth. See what is apparent depth. So it is apparent depth. For example, this is now boundary. Now consider an object at some depth. Consider an object at some depth. So take it as O object. Let us take this is now medium one. in which object is there. That means we are getting light rays from the object. Okay. So from which medium light rays are coming, that is medium 1. Now when we see from the second medium, this object appears to be closer to surface, or it may appear away from surface, which depends on the relation between the refractive indices mu1 and mu. Okay. Let us now carefully observe relation between. Let me take this point as A. Then AO. This is now real depth. Okay. Let us see what we observe. So light rays traveling like this. This is now point of incidence. I am taking normal at a point of incidence. Point of incidence. Suppose this enters, means traveling from a denser medium to rarer medium. Then light ray bends away from normal, means like this. Now extend the rays back. Extend the rays back. So if you observe, let us, this is now our eye, okay? This is our eye. We feel that light rays are coming from this point. This is now image, okay? That means AI stands for apparent depth. That means when light rays are traveling from denser to rarer medium, object appears to be closer to the surface. It is object appears closer to surface. For example, if you are looking at fishes inside water, the actual depth of the fish is different from the depth what we observe. Okay. Let us now relate this actual depth AO and apparent depth AI. Okay. Let us take now it is A, take this point as B. We can see this is now angle of incidence. This is angle of refraction. This is I, means this also I, right? Alternate angles. This is R. This is also R. Okay. Now see what we can write here. I am taking here triangle. Triangle AOB. Triangle AOB. See in this what we can write. Tan I is equal to opposite by, opposite is now AB, right? Opposite is AB. AB by, it's a height. So take it as it is height, take it as H. Height, or you can say depth, okay? Depending on the problem. In this, it is depth. If you're taking reverse, it is height, okay? Next, consider triangle. Triangle. It is AIB. From that, we can write tan R, that is equal to AB by, take it as H dash. Okay. Now here we consider one special case, that is I and R. I and R are small. If you take they are small, tan I approximately equal to sin I. Approximately equal to sin I. Tan R approximately equal to sin R. Okay. So condition is that here we have taken I and R are small. Okay. Right. Now see what we get. Sin I by sin R. Sin I by sin R, that is equal to, see what we get. Sin I by sin R. It is H dash by H. Okay. Sin I by sin R. And this gives us refractive index of second medium. See from Snell's law, mu1 sin I is equal to mu2 sin R, or sin I by sin R gives mu2 by mu1. And we are reading this as refractive index of second medium with respect to first medium. I am repeating, sin I by sin R gives refractive index of second medium with respect to first medium. Okay. Now from this, see what we get. H dash apparent depth is equal to mu2 by mu1 into H. Okay. Now see carefully. If mu1 greater than mu2 means light rays traveling from denser medium. If mu1 greater than mu2, then see what happens. This value will be less than H, right? This total value. That means object appears closer to surface. So best example is, you can say fish. Fish is in water and we are seeing from air medium. So for us, fishes appears to be closer to surface. Okay. Now take reverse. There is a fish. There is a fish and here is a bird. Fish is now looking at the bird. Fish is looking at the bird. Then bird becomes object. Then light rays coming from the bird reaching the eyes of the fish means light rays traveling from rarer medium to denser medium. That means now this mu2 becomes rarer medium, or take it as to avoid confusion. This is mu1 and this is mu2. So which one is mu1 means in which medium object is there, or from which medium light rays are coming. Now fish is looking at the bird. So light rays coming from the bird reaching the eyes of the fish. This is mu1. Now mu1 is less. You can see here mu1 is less, mu2 is more. This total value is now more. That means for the fish, bird appears to be at more distance. If actual height is h, actual height, the height which it appears for fish appears to be is more than h. Okay. So conclusion one is, if object is in denser medium like fish, okay, bird is looking at the fish. For the bird, fish appears to be closer to surface. For the fish, bird appears to be at a more distance. Okay, let us now calculate here. I am taking object. Object is in denser medium. In denser medium. That means I am taking a fish as object. So to make it simple, taking fish is now object. F is for fish is object. Bird is looking at the fish. So for the bird, fish appears to be closer to surface. Therefore, apparent depth is equal to, if I'm generalizing, this is air and this is water, then see what happens. Mu1 is mu. I'm taking it as mu. Okay. I will make a diagram here to avoid confusion for this case. Fish. This is mu. Bird is in air. Mu value is 1. This is 1. So mu1 is mu. Substitute here mu1. It is now mu. Mu2 is 1. It is now h upon mu. Apparent depth equal to real depth by mu. So what is now shift? Shift equal to h into 1 minus 1 by mu. So you can see here actual depth is AO. Real depth is now AI. Shift is how much? It is IO shift. That means H minus H by mu. That is now shift. Now takes next case. That is object is in rarer medium. Object is in rarer medium. Example is bird. Bird is object. Fish is now looking at the bird. Okay. I will make a diagram here. This is now bird. So here mu1 is 1, mu2, mu2 value is mu. Because rays coming from bird reaching the eyes of fish. Okay. Then see what happens. Substitute here. Mu1 it is 1, mu2 value mu. H dash equal to mu into H. Okay. H dash equal to mu into H. Means for the fish, bird appears to be at more height. Okay. Therefore, shift equal to h into mu minus 1. Okay. So object is in denser medium. Shift is h into 1 minus 1 by mu. Object is in rarer medium. Shift is h into mu minus 1. Okay. So this is now regarding upper and depth. In the next class, we can solve questions based on refraction. Okay.